Hi everyone, welcome to our support live stream. I'm joined by Michael Nolan, Senior Engine Programmer, and Zach Parrish,
Hey.
DevRel Tech Artist. I'll be your mod today. My name is Sean. I'm
You don't even know who you
Developer
are.
Support Manager. There we go.
This is just Sean.
We'll be covering Paper 2D in 4.6. Please submit your questions in the Twitch channel. I'll be monitoring those and sharing those with Zach, who will be presenting.
I'm trying not to table flip right now. You blew that intro
sorry,
so badly. No, I mean, the whole vibe is just wrecked now. So, hey, everyone. Today we're going to be talking about Paper 2D, best practices, working with the system, actually doing fun stuff. Hopefully, if you're watching this live stream, you're at least familiar with the YouTube videos over Paper 2D, which is kind of an intro. What we did in those videos is we took the Paper 2D side-scrolling template and we rebuilt it from just the textures. What I've got here in Unreal is a game that I put together a little while back. I think I started this while I was at Gamescom. I was working the booth, and I was kind of bored, and I had a drawing tablet and a laptop. Here, I'll just make everything nice and big. So I've got a little 2D character. He runs and moves around kind of a lot like the guy from the template, but he can do some other stuff too, like he can sneak around. And he can shoot fireballs because I felt like if he couldn't shoot fireballs, the game really wouldn't be complete. And then we added some other fun stuff too. So he can do the little Spider-Man looking jump, and he can do little wall kicks. And what I wanted to do was kind of talk a little bit about how this system came together, because the Paper 2D aspect of things, the way the plugin itself works, is actually fairly straightforward, right? You're going to bring in your 2D texture, you're going to split it up into some sprites, make that into some flipbooks. But then what do you do from there? And really, it's up to you, but there is some work to be done. So what I wanted to kind of start off with here is just walk you through some parts of this this project. Also, I want to mention that this project is something that I'm still kind of cleaning up, and here within the coming days, I'm going to be putting this up on the Learn tab for everybody to have a look at, so that you'll be able to take this apart. I just have to remove some of the used paper cups and empty beer cans that are lying around inside the project. So one of the things that is important to keep in mind about Paper 2D is that it doesn't currently work with our existing animation blueprint system. So you're not going to create a Paper 2D character and just plug it right into animation blueprints. So what I've done here to make this character have all of these run around and play behaviors is I've built a state machine here inside of Blueprint. So I just wanted to kind of give a quick run through about how this works. So we have a custom event called Update Animation, which is doing a couple of quick checks. I mean, we want to make sure the character's not spawning because we're doing some fancy things with spawning. You might have seen the pencil draw him in, and I'll talk more about that a little bit later. We want to make sure that if the character is falling, that we're taking that into account. We're storing up his speed because we're going to need that as well to make sure we know whether or not he's moving. And then we made a custom function, which is really just a great big state machine. And it's important to keep in mind the type of data that this is pulling in. So we're storing how fast the character's moving, which you saw we just grabbed, whether or not he's crouched, whether or not he's jumping, falling, firing, spawning, all kinds of stuff. There's even one called blank, and honestly, I don't remember what that was for. So once we have all that, we can step down into the function. And the idea here, as any state machine is going to go, is really we just start with the data we have on hand. And because of the way I like to work within functions, I made local versions of all of those incoming variables. If you don't yet work with local variables inside of functions, I can't recommend highly enough that you get used to using them. They make it a lot easier to play around with the data that you bring into any given function. Now, once we've got all of those stored in local versions, we've got a bunch of if-else checks to see what the player's doing. And you can see they're named accordingly. So check and see if we're dying, and that's just a collapse graph. So if I jump inside this, we just say, hey, is the character dying, yes or no? And if I jump back out from there, you can see if we are dying, then we have our true, and we set an enum, which consists of all of our states. Now, if you're totally new to the whole world of enumerations, you can create these inside of your content browser. So here I've got an animation states enumeration, and you can see what it includes. So we've got things like idling, running, crouching, crawling, jumping. All it is a list of named states. That's it. So what we're doing here is we check and see what the player's actually doing. Are they dying? Is he being hurt by something? Is he running? Is he crawling? And then based on whether we find those to be true or false, we either set that state to be true, basically say, all right, we have decided that he is crawling, so we set his state to crawling. If he's not, check the next thing. Was he jumping, yes or no? Once we've collected all of that data, once we know which of these states he's actually in, then we have our final part to the state machine, and this is where we essentially just use that state in a select node to figure out which animation flipbook to play. So here are all of our different animations. We have one for idle, running, crouching, and so forth. So if I grab, let's grab the crawling one, for instance. If we jump over here. This is that part where Michael could be like filling in the space with something, but he's not, which,
I'm watching you flounder. It's okay.
That's totally cool. So here's like his crawling animation, as you can see. I totally mocapped that, by the way. So let me jump back over to our blueprint. So once we have that, we simply set the output flipbook, and then that's how we know what the next animation is that we're going to play. So if we go all the way back out to the outside of the state machine, this is all we do. We take our target sprite, which is the sprite for our main character, and we're just setting what flipbook is applied to it. So this is kind of an interesting technique that you don't really see. You see, I guess, in a very, very small scale within the animation template, or sorry, in the template for Paper 2D. I think we're just selecting between idle and running, and that was it. So this was something that has a lot more going on. Now the question then becomes, like, if you're totally new to this, well, where do you get all of these other Booleans? How do you know if he's being hurt? And really, that's where the rest of your blueprint graph is going to come into play. So for instance, if I'm just kind of moving around through this, so we've got all of our different controls. These are really almost exactly the same controls that exist in the template, because again, our character really just runs left and right. We have a special input for jumping, and then if we are not falling, actually we had to be kind of clever here. We had to say, if he's not falling, play the jump animation, because when you play the game, let me show you this real quick. If we hit play, notice that he kind of has a little jump animation. He leaves one leg kind of dangling for just a second, and then he goes into his falling animation. And we needed a way for that flipbook, that jump flipbook, to play only once. So what we did is the moment we jump, we check and say, are you falling? And if you're not falling, then play the jump animation. And then as soon as he switches over to falling, then we check and see if he should be wall jumping. And it's all handled kind of in his states. Actually, let me here you go. Here's the jump animation event. So the moment we detect that he needs to jump, we say, all right, cool. His state is now jumping. We say he is jumping. And I literally had to hard code this because at the time, Michael, this is where the camera clicks back to me staring at Michael awkwardly. At the time, there was no way to see how long a flipbook was. I don't know if there is yet.
Yeah, there is.
Awesome. So when I put this together, there wasn't. So what we did instead is we did a little bit of math. We said, here's the frames per second by how long the thing plays. So now we know how long to wait. So basically, this delay works out to be just exactly as long as the jump animation is when it plays once. So we are jumping, we wait until that animation is done playing, and then we say, we're no longer jumping, But because his state will now be falling, he goes into his falling animation instead. So it's a lot of kind of jumping back around, kind of flipping through animations, which I'm sorry, that was horrible, what I just said. Now, I guess the only other thing that was a little difficult to really sort of figure out, having never done it before, was really handling how his capsule changes shape when he crouches. For example, let's just close this, I'll reopen it if I need it. I hit play, and then, let's go full screen. And I hit the tilde key to bring up the console. We'll do show collision, and now you can see his little collision capsule, right? So when he jumps, I wanted his collision capsule to get smaller, and when he crouched, I wanted that to happen as well. And there's actually a special way to handle this with characters, or at least at the time this was assembled, there was anyway. There is a property called crouch maintains base location. And that is tucked away inside your character movement controller. So let's see if I go
Show inherited variables.
Thank you. The screen's so far away. So actually, probably easier if I go over to components first. So go over to character movement, and then just search for crouch. So let's see. They might have changed the name of it. Well, I'm not even seeing it anymore.
Is it on the movement component or is it on the character itself?
I thought it was on the movement component. Well, hang on, let me just look back at my graph. No, it is on the character movement component. So there is a property in there called, here's the catch to it. You can't actually check this manually. You can't work with this.
So it's only in the graph.
It's only in the graph. Now, a long time ago in a galaxy far, far away, depending on which version you were using, you could actually see this checkbox, but it was grayed out, and you can't actually change it. You can't check it inside the property list. But I knew it was something that I needed to change. So after working with it, it's a property that has to change dynamically. You can only change it at runtime. So what I end up having to do is say, if we are falling, then we need to adjust this property, and if we're not falling, we essentially need to switch it back, which is what this whole section of the graph is all about. The way this works is it tells the capsule that it needs to scale from its own base. So I'm talking with my hands, so it's one of those fun things. But so the idea is that when your character capsule squashes down, instead of squashing toward its center, it's going to squash down toward its base. If you don't do this, the problem is when the character lands, so he jumps up in the air, his capsule gets smaller, and then he would land, and his capsule would extend
Shoot
again.
back through the floor.
And it'd go down through the floor, and he would get stuck, and horrible things would happen, and the game became unplayable, and people flipped the table, and there was much gnashing of teeth. So we discovered this property, or we, being I, having never done this before, discovered this property that allows you to scale from the base instead. The trick is, though, you had to turn it on when he goes airborne, and then turn it back off after he lands. So there's kind of a little bit of toggling going on there. Definitely worth checking out when we get this up in the Learn tab, which again will be coming in the next couple of days. The other really fun thing to set up, I think this is probably the most fun I had in the whole part of the project, was figuring out the wall jumping mechanic, because that was something I wanted really early on. I've always loved wall jumping. I think the first time I ever saw it in a game was the original NES Batman. So Batman would run and he could like jump off a wall and just continue going up. And of course it's been done in like Mario 64 and a million other games since. Now the way we're doing this is, and I think there's even an apology in the comments that it's kind of messy. And I typed the word maths to make all my British friends happy. So essentially what this little red box worth of nodes is doing is it's creating a second capsule that goes outside the boundary of the base collision capsule for the character. So it's kind of like an extended radius. And if there is another object, specifically like a wall, within that radius, then we know we're up against a wall and we know we should be doing a wall kick. It's like two things you have to check for. One, you have to say, are you airborne? And two, are you up against a wall? And if you are, it's time to wall kick. So there's basically all of this is how we came up with the math for drawing that capsule. And then we draw the capsule. So I can show you that real quick. Let's take the debug type and we'll set it to for duration. And we'll compile. So now, actually, I'll close that again. And let me hit F11. So now as we run, if I find the great big wall over here, boom, every time I hit jump in midair, it does this little trace. So it's trying to do that capsule trace, and it's not finding anything right now, and I don't know how well that is, how easy that picks up on the screen. It looks a lot better across the room. But if it finds something, you see you get a green capsule, and then it fires off the rest of your equation, and you get a nice little wall kick. Now, knowing that, let's jump back over to our blueprint.
So real quick, one other neat trick for working with a single monitor and doing blueprints and testing like this is switching the play in editor mode to new window. And then you can just hit play right on the toolbar here without having to keep moving the windows around and going
I
back
should
and forth.
totally do that like all the time. Where's that hiding? Is
New
that
editor window.
New editor window.
Yep.
Oh my god, I'm so excited right now.
And so now you can just maximize the blueprint and hit the play button on the toolbar there.
I feel like I should have known that. There you go. Sweet. So after we draw that, we just do a really quick check. Did we hit anything, yay or nay? And then based off those results, we do a couple of quick little checks of math. We say, all right, what was the normal of what we hit? That's how we know what side, or basically what direction the wall was facing. We get that normal, and we multiply it by how far we want to jump. So there's kind of our jump magnitude right there, which that's hard-coded and something I had to play with to figure out a good number for. The other thing I had to figure out after a lot of testing was I had to kill out his existing velocity. The problem here is if he's falling down a really long chasm or something and you want him to jump off of a wall, if you don't do this, he's falling down the wall really, really fast, and you hit the button, he just bounces off the wall and continues falling at full speed. So you got to take his existing velocity and essentially zero it out so he can fall and then bounce back up, which I can demo real quick now with my cool little expanded window out here.
And that's something you could play around with, like if you wanted to get sort of an N plus sort of sliding down the wall, like where he can't quite fully do it, you could take away 80% of the velocity or something like that, so he's not 100% of it.
And I did play with it for a while. I just, for me, I really loved the ability to just like get really close to the ground and be like, oh, nope, I want to go back up now.
That reminds me a lot of Strider.
Yeah.
Oh, yeah. I tried to play the remake of that and wasn't super
It was really hard.
enthused. Yeah. I'll have to give it another try. So anyway, we've got a little function here that launches the character. Really, that's just adding the velocity that we've solved from figuring out what direction the wall was facing, multiplying in our jump magnitude. Once we've got that, we set the controls rotation. This is literally just flipping the character. Because if you don't do this, if he's like facing to the left and he jumps, he'll still be facing to the left. This just flips him around so he's rotated in the right location. And then we play our jump animation when all that is said and done. So it looks pretty big, but it was actually a fairly easy setup at the end of the day. Now, I realize that there will probably be a lot of questions about how all this works and how to use it. Again, like third or fourth, fifth reminder, this is a project that we're going to be throwing up into the Learn tab so that you can play with it on your own and take it apart and ask questions. Just keep in mind that it's really like I guess not entirely polished. It was just something that I put together mostly for the fun of it, to figure out how some new systems work, and that's how I encourage you to go into it. Just use it as a way to kind of explore different things that you can do. Now, what I want to do before we jump into Q&A is show how we can expand upon this game. So I wanted to add a bad guy to the game. Now, in truth, the game is already set up to have bad guys. There's already some code inside, and I use code loosely, right? There's some blueprint scripting in the game mode that allows us to spawn an enemy. So we have an enemy class slot. If that has any value whatsoever, if we have fed this any kind of a class, then we're going to fire off the spawn enemy timer. And all of this is essentially figuring out where the character is and setting up two theoretical spawn volumes, he said with fingers, so two spawn volumes on either side of the screen. And if it's on the right side, the characters will be moving left. If it's on the left, they'll be moving right. So they're always kind of moving in toward the center of the screen. So let's make a bad guy, just kind of for the fun of it off the top of our heads. Now, when I was doing the little bit of prep for this live stream, I realized that I needed a new sprite, and I didn't know if Photoshop was going to be on this machine. So I brought in a drawing of a potato. So I figured I would make a bad guy out of a potato, and it gets to reinforce a little bit of the Paper 2D workflow anyway. So let's start. We'll just right-click on this texture. It's just a PNG file, and we'll make this into a sprite, and we'll call this the potato sprite. I think I need better glasses. And there you go. We have the best sprite ever. So we should probably adjust a few things about it. Its source region, I'm sure, is fine because I'm not seeing any scraps or anything else hanging out inside the sprite itself. The collision is a little on the rudimentary side. So let's see here. We could probably fix that up. Let's just shrink wrap it. We'll just ooh. Well, we'll kind of be lazy, but we will clear out some of these extra vertices which are floating. Now,
the shrink wrapping's been improved dramatically for 4.8. It won't be in 4.7, but it's coming.
Awesome. See, that's actually why Michael's here. It's more than just to sit here and judge me for using his tools the wrong way. It's also to feed us valuable information about what's coming on the horizon. Oh yeah. So and now if you are doing any sort of shrink wrapping and you see results like this, what it probably means is you had a bunch of random scraps in your alpha channel. So little bits of pixel data that are just kind of floating out in space. Now the good news is they're color coded, so the white vertices you probably don't need, probably.
And you could also just use go into collision edit mode and then just click around the potato to add points to it as well.
I know, but I was hoping this would be faster. I was trying to, cut corners.
Yeah, I understand.
He said jovially. All right. So cool. Now our potato has the most excellent collision that he could possibly have. All right. So now we could, naturally, we could just bring this right into the world. We could take its, make sure its location is set to 0. I mean, you don't necessarily have to have your game at 0, but it's pretty good practice, right? To make sure that when you're building your game, you have a common location in the y-axis, and 0 seems to make the most sense. That way anything that needs to be in the background can have a negative y, and anything that needs to be in the foreground can have a positive y.
And that's another thing that we're going to improve for 4.8 as well. We're going to have basically a layer snap, so when you drag and drop something into the viewport, in 2D mode, it'll automatically snap to a particular plane, and you can pick which plane.
I'm so excited by that. Because I've had to do this like a million times now. You drag something in and then
reset
set its value. Yeah. Such to the point, actually, not to digress or get too sidetracked, but I have a blueprint here called level structure. It's basically how I built this level. Check it out. So you bring this in, and it's got a sprite, and it has a little tiny widget in the middle of it, and you just drag the widget out, and it creates a platform. And it rotates too, so it all just kind of works. But I realized I was having to reposition all these guys, so in their construction script, they set their own Y translation to 0.
They just force themselves to the right plane. Yep.
Yeah, it made me very happy. Now, the problem with that is, of course, you can't really have this thing be anywhere other than Y of 0, but,
You can make that a property.
I know. I just hadn't. Anyway, so let's see. Let's go back to the potato. So we got the potato, and then just for the fun of it, let's tell the potato simulate physics, and we'll play. Oh my God, raining potatoes. That just makes me so happy. Okay, awesome. So let's turn this into some kind of a bad guy. So to do that, though, first off, let's get rid of the sprite potatoes. Let's make a new blueprint. And we'll base it off actor, because it's really just going to be something that will live in the level. And we'll call this the potato. I can't see that far away. Potato enemy. I think that's right. I mean, if it's wrong, you guys are going to laugh at me later. It's fine. Now, this is going to need some stuff. So it's always asking for a scene root. Now, this is mostly one of my workflows. It has nothing to do with really anything else. I will tend to put a scene as my base root for just about everything.
Yeah, same here. And that way you can always adjust the pivot around and stuff like that.
Yeah, because if you don't do this, so the next thing, look, I'm just going to take my sprite and drag that right into the component list. But if I decide that I need to offset that at all, I've got to have that scene component in there in order to create those offsets. And we'll call this the potato sprite. Awesome. Like what I really want out of this, now, did anybody in the room play Castlevania?
Yeah, of course.
Good. Then I don't have to get any crazy wisecracks about how old I am to remember that game. So Castlevania has these enemies called Medusa heads or whatever, right? And they just wave up and down and come in and kill you. I'm the worst in the world at surviving Medusa heads. So let's make a character or an enemy that works kind of like a Medusa head. Now, Medusa head has two things that it does. It moves forward and it waves up and down. I'm totally going to cheat with the forward moving. We are going to go under our component list and I'm just going to grab a projectile movement component. This is just going to give him a